after I met the scholars and I learned like how interesting and how formal is the Panini's grammar. So it became, so out of curiosity, we were planning to see if we can somehow create a computational implementation of Panini's grammar. So this work started in 2007 when we went to University of Hyderabad, and Professor Amba Kulkarni actually organized a workshop where we had computer scientist students as well as Gurukula students, and we were trying to learn from traditional scholars what is the structure of Panini's grammar, and we were trying to at the same time see what are the corresponding programming concepts. And of course, as the scholars have just mentioned very nicely, there are many phenomena for which we could not find a parallel, like what is the corresponding parallel in the computing paradigm. So another big motivation was, can we discover new paradigms while we try to simulate Ashtadhyayi? Though this is not possible by the current paradigm, are there new computer paradigms that need to come out? So this was where the work started. Yeah, I had not been a very good student in the sense that, the work started in 2008. That time I just started my PhD. And then, I moved on to some other field in my PhD. But then somehow, during my postdoc, I went back to Kendriya, Paris, and working with Professor Gerard Huet on his Sanskrit heritage site. And I happened to meet the group, so we already heard from Dr. Tanuja also, Dr. Anuja and Professor Peter Sharp, who were there. So with them, again, we started thinking about a computational implementation of Panini's grammar. So that is where the second work that I did, and that was when I was doing my postdoc in 2013. So that came out. So this was presented in the Sanskrit syntax workshop in Paris. Now the first work, computational implementation, so this was on the Subanta. Actually, it only worked for a subset of Subantas. So we worked only on Subantas. In the second implementation, we worked on the voice prevalent transitivity restrictions in Sanskrit verb usage. And I show some brief examples. So this was the second work that I did. That was when I was doing my postdoc. So the three implementations were at different stages of my career also. The third work was presented in the 16th World Sanskrit Conference in Bangkok, so in 2015. And here I had my MTech student Amrit Krishna, who was leading the work. And here we were trying to implement the simulate Panini for Tadita section, derivative nouns in Panini's grammar. Now, so there are papers with all the three works, and there are a lot of nice insights that we have got. But I'll just be very brief in what we were trying to do. So we were trying to discover programming concepts, techniques, and paradigms that are employed by Panini. So this was the main objective. And for me, as a person who did not know Panini grammar, people can, of course, argue this is not the best way to learn Panini's grammar. But this was my motivation, that also learn what was the interesting ideas that the grammar has by doing the simulation. So yes, of course, when we used to talk to scholars, they are like old times. I don't remember many of the things now. So the last work I'm showing is 2015. It's already 8 years since then. And I have moved on to a different topic like that I will just show briefly towards the end. But there were many nice discussions that used to happen. Like when we are simulating Panini's grammar, what do we mean? Is it only Ashtadhyayi that is given to us, or also Vartikas, Mahabhashya? So what is the underlying set that we are trying to simulate? And there were also questions. We thought a computational simulation, if it is faithful to Panini grammar, it can actually be used that, okay, there are certain interpretations where I can make a switch, that I can turn on this interpretation and see what is the output of my system. And then I turn off this interpretation and see what is the output of my system. And if I apply it for many cases, maybe I would know which interpretation actually leads to certain problems. I can automatically see that through the implementation. So this was the motivation with which we were working. Like, for example, conflict resolution and mood triggering. So we know about the Utsarga, Apavad, Antaranga, Bahiranga, Nitya, and Parapurva. So in this conflict resolution, so there were certain scholars who believed that only Parapurva is sufficient. Others used to say that no, we have to take care of all of these resolution techniques. So can we also take it as a pluggable entity in the system and see, okay, if I apply only Purva Para, Then what are the cases that are resolved? If I apply everything, what are the cases that are resolved? Similarly, like Professor Peter Shah in his 2010 paper that was presented in the Vyakarana section of the 14th World Sanskrit Conference, he talked about the specificity hierarchy that can be treated as a way for conflict resolution. That you can think about rules that are talking about phonetics, the phonological, morphological, semantic, and there is a hierarchy, priority. And if you go to higher level rules, they should be preferred over the lower level rules, lower level conditions. So again, we try to make it as an entity that can we apply a specificity hierarchy in our conflict resolution and see whether this tries to resolve. So initial programming model was very, very simple. So where Amba ma'am had already talked about a data space age. So this is actually from that paper where the initial model was shown. So we had a data space that is, because we are implementing in a computer, we have to maintain what is the current form of my prakriya. That is our data space. And there are all the rules that are observing that data space and they are seeing, am I applicable at this particular time? And whenever a rule finds applicability, and if there are multiple rules that are applicable, they are sent to this conflict resolver module. And as I said, this can be a module that can work with various sorts of vartikas, paribhashas, and see what happens if I apply this versus that. And then there will be a winner rule that will be selected, and this winner rule will modify the data space. And there were many, many interesting issues that came up with asiddhavat and asiddha section, and that's where the complicated diagram that we had to resort to. And among the three works, this is the only work that is actually available. So thanks to Amba ma'am for preserving that. So if you go to Sansadhani, so I tried this Rama, the Pratipadika Rama with Shashti Pullinga Bahuvachan, and it gives a derivation. Right? And if the final form is correct, at this point, I cannot vouch for the correctness of the rule triggering mechanism and whether the correct rules were triggered, but I'm hoping this was fine. So it would actually go through all the rules. It would find out if there are multiple rules applicable, what is the correct rule based on the conflict resolution. And so this happens at multiple stages here. And finally, it gives a derivation. So this was the derivation, the first derivation that we worked with. The second derivation, so 2008, that was the part. And then, that I did not take it further. Then in 2013, we worked on a slightly different part. This was much more smaller part of Panini's grammar. So that is on, I don't have much time, I'll just quickly tell. So these were the verbs and voice assignment. So, and these rules are from 1.3.12 to 93. So they give various restrictions on what are the preverbs you can apply to different verbal terminations. So, and there are various conditions. For example, there are root markers, there are prayoga, co-cres conditions, preverbs, meaning conditions. All of these are there in these 82 sutras. So what we wanted to do, we wanted to make this as a native adjacent system so that we know, as per Panini grammar, what are the affixes that can be applied to a root with a preverb. For example, the root neh vishaha, 1.3.17. It says after the root vish, when preceded by the preverb ni, atmani pada affixes are employed. That means that a generative system should not employ a parasmay pada affix after this, because the Panini has said that you should not do that part. So you can avoid overgeneration. And there were other motivation for finding semantics. So for preparing the data, we had used Madhviya Dhatu Vritti, and then we had taken the attested preverbs for roots that are coming both from Panini grammar, and they were root alignment, all thanks to Anuja and Tanuja this first time. Our implementation, so that's where we moved slightly from the 2008 implementation. So where we were saying, Prakriya, we will have a form. So what is the current form and what are the attributes, list of attributes that we are finding. And we were preserving for each rule, for what is the attribute can be from a particular position in the form. So we were also preserving that for each attribute, what is the start and end of the form where the attribute applies to. And we were deriving with whole essential information and all. This was the structure very similar to what I showed. You have initial prakriya, you have a set of rules, you match conditions, find out triggered rules, and then you find out which one is the prior, which one should be given priority. So here is one example of this was some nice output of this work, so we could automatically generate these nice graphs. I'll go back to my, somehow this is not showing fully. So here, if you see, what we would show as an output is, if we start with the root bhu, and we say what are the possible upsarga that can be applied, and sense and swara. So we go through all the Pandit rules and see what are the prayogas that will come out and under what conditions. Like we find out that in bhava and karmani prayoga, we will have atmanepada. And then there is a parallel branch that goes out. Okay, if prayoga, what is the complementary to bhava and karmana? It's a kartri prayoga. So that we have immediately a branch kartri prayoga, and accordingly the rules will get applicable. Like 1.3.16 will get applicable, but what is the complementary would be here. Right? And correspondingly, we'll find at the end, while going through this branch, here we have parasmepada, atmanepada, and parasmepada. So these are the things, and I should not take too much time about this. So this is the final work on Tadita that was mainly done by Amrit Krishna, my then MTech student. So where we tried to model all the Tadita rules. And this has a very nice inheritance hierarchy that, so for example, there's a main affix that is applied, right? There's this adhikara section for earn, but earn is also applicable somewhere else under thakya. And a special condition, we have earn. Right? So there are pratyadhikara, arthadhikara, and there are exceptional case rules. So to solve that, what we did, we created a rule triggering hierarchy. We said there are some top level rules that are observing the environment, and within top level rules there are same head rules. So they can be many like the adhikaraj. So R1, R2, RG3, they are main rule groups, and within each rule group there are further exceptions that are coming out. So they only get triggered, and once you go to one particular group, then you go to another inside that. Right? So this was one example for Chataka Gasapatyam that we get from our system. So at that time, there were many future directions that we had found. For example, conflict resolution in entire Ashtadhyayi, what is the role of a specificity hierarchy? So that is something we wanted to actually find out. And Amrit Krishna, my student, got very much interested in seeing Pandit grammar as an instance in optimality theory, that how we can model the constraints. And then can we learn these constraints? So now this is something may not be doable at all, that how can we learn the kind of constraints or rules that Pandit has given for languages other than Sanskrit? If we are just given the usage, can we actually learn that? So this is a question. So as I said, currently for last 8 years, I moved from Pandit's grammar implementation simulation to something more on the analysis part, that can we develop tools by which we can analyze Sanskrit text. And I believe Jivnesh Sandhan yesterday might have given a demo about Sanskrit Shala, where we have developed neural models for doing word segmentation, morphological tagging, dependency passing, and compound classifier. There is some instability on the web UI that we will try to solve soon, but these tools are working, these tools are currently running. So this is where our main effort went. Even Amrit got interested, and that's where we developed a lot of data sets and tools. And recently we have, so actually that is how I came in contact with Kshetresh Professor, and so we have a whole team who are trying to work on using Pandit's grammar for doing something in general Indian language, especially in the space of Indian language translation. So where we can use Sanskrit-based interlingua representation for doing a faithful translation between Indian language. And the idea is that we go from a source language, can be Hindi or Kannada or any Indian language. We try to go to a universal feature representation that is motivated by the linguistic features that are in the Pandit framework. And from there, we go to the target language. And the main idea for us is that can we come up with a markup interlingual language where for each word, we can say what are the different morphological properties. And these will be they are all inspired from the Sanskrit tradition on different morphology, karka, and lexical semantics. So this is a work in progress, and so with that, I would like to thank again for inviting me. Thank you, Anif.